It began like any other deep space scan, routine, methodical, almost boring. The James Webb Space Telescope was monitoring the asteroid belt between Mars and Jupiter, charting thermal data and motion patterns among known debris. But then something moved, not in a predictable orbit, not in a natural line. It drifted, then decelerated, and for a moment time in the control room stopped. This wasn't a rock. It wasn't ice. Spectral scans showed metal, heat-retaining, engineered metal. It emitted faint electromagnetic signals. It moved against the pull of gravity. And that's when the question hit harder than any asteroid. What is it doing here in a neighborhood we thought we'd mapped completely? Something has arrived or awakened, and it's behaving like nothing we've ever seen. Is it alien? Is it ancient? Is it watching us? This isn't science fiction. It's JWST data, real, unexplained, and active. If you've ever wondered what the first sign of non-terrestrial technology might look like, this might be it. The unexpected intruder. The alert went off in JWST's mission control room. A fast-moving object appeared between Mars and Jupiter. Initial reactions ranged from elation to stunned silence. As the data came in, this wasn't an asteroid, comet, or known probe. The trajectory was puzzling, weaving in a path that didn't match Keplerian laws. Scientists exchanged looks. "We've never seen this," one said. Spectral scans delivered the punch. Strong metallic signatures, surprisingly high thermal retention, and faint but consistent electromagnetic emissions. Rocks reflect sunlight. This thing glowed from within. It wasn't a natural stone, ice body, or gas blob. Engineers double-checked systems, and the results stood firm. This was new. The team dug into thermal inertia analysis. Materials that don't cool quickly, like metal, fit best. In the chilly belt of asteroids, that makes little sense. JWST could track tiny radiant differences, and it was seeing something impossible, an object shining with internal warmth. To grasp how unusual this is, we need to review the asteroid belt itself. Here's our cosmic neighborhood. Thousands of diverse bodies locked in stable paths. Any object here should behave predictably. So let's see why this interloper defies everything we know about the belt, and why astronomers are suddenly rethinking it. A known neighborhood nestled between Mars and Jupiter lies the asteroid belt, a region packed with millions of rocky bodies, ranging from dust grains to dwarf planet-sized series. The belt is stable and predictable. Our instruments have mapped asteroid families and their orbits, spin like clockwork around the sun. Embedded within our special Trojan and Hilda groups, objects trapped in Jupiter's gravity, collected in known parking spots. These zones illustrate cosmic order and motion. JWST routinely confirms their trajectories, ensuring nothing escapes the rules. This object, however, doesn't conform. It drifts like a dancer breaking formation. No family association, no stable pattern. Its chemistry doesn't match carbonaceous chondrites or silicates. It's neither typical asteroid nor icy comet. It simply doesn't belong. With mapped orbital lanes and known bodies, astronomers were confident in what they'd see. This intruder snapped them back to reality. Space is still full of surprises. Now the question becomes, where did it come from, and why is it here? To understand the detection itself, we need to know why JWST is so well suited for spotting faint moving objects. Its infrared eyes and tracking precision allowed it to catch a mid-flight slowdown, something only the most sensitive instruments could reveal. Let's break down how JWST did it. Deep dive. The James Webb Space Telescope has infrared vision that surpasses previous systems. Its imaging and spectroscopic abilities let it measure thermal emissions and chemistry, even on faint bodies in the asteroid belt. This enables scientists to pick up metal lines and faint signals otherwise invisible. JWST also excels at mapping thermal heat from small bodies, tracking how they glow at night and cool in sunlight. By snapping consecutive images, it detects minute motion. That's how it saw the object break mid-flight, subtle shifts that defy gravity's natural pull. To ensure accuracy, JWST works with radar and telescopes on Earth. Observations cross-reference data from facilities like Goldstone or the Subaru telescope. Coordination strengthens the conclusion. This isn't a glitch. The slowdown is real. Then came the defining moment. During one thermal mapping sequence, The object slowed its velocity by meters/s in minutes. That kind of deceleration doesn't happen naturally. An enunciated signal flashed on screen. The object wasn't drifting. It was controlling itself. Clue number 1. When JWST examined the object's spectral fingerprint, it lit up with metallic emission and absorption lines. These patterns didn't match rocky or icy bodies, which produced different signatures like silicates or carbonates. Instead, the readings aligned more with strange alloys, something engineered or unfamiliar, not typical asteroid minerals. Next came thermal inertia measurements. Metals cool slowly after heating, retaining heat far longer than rock or ice. In the cold asteroid belt, that means the object glowed subtly between sunlit exposures, like a heated iron rod left to cool overnight. That's not normal for natural belt objects. Even more intriguing was a faint electromagnetic buzz detected in the radio spectrum. It was low power but steady, far beyond background noise, yet weak enough to have passed unnoticed until now. That signal hinted at internal energy or passive electronic activity that needed ruling out. These clues together, alloy-like spectra, persistent heat, and an EM trace, pack a punch. They rule out typical carbonaceous bodies like C, S, or M-type asteroids. Comparisons to meteorite samples showed no match. The data strongly suggests either metal-rich composition, possibly artificial, or something genuinely extraordinary. While the spectrum reveals metallic makeup, it's the object's motion that seals a mystery. It isn't drifting, it's actively maneuvering. Gravity alone can't explain those mid-course corrections. Let's follow the trail where JWST witnessed it break and turn, defying orbital dynamics, and why scientists are calling that movement intentional. Clue number 2. A deep dive into the trajectory data uncovered something startling. During travel, the object slowed and shifted laterally, actions that defy Kepler's laws. In the asteroid belt, gravitational pulls alone dictate motion. But this object didn't coast. It executed deliberate changes in speed and direction. JWST logged multiple instances of acceleration and deceleration tracked over hours and days. These weren't subtle gravitational interactions. These were controlled, intentional moves. Even small thrusters could explain that behavior, but no natural force fits. Gravity, solar radiation pressure, or collision models all fell flat. To confirm, the data was cross-checked with JPL and ESA's observatories like Odin. Both independently confirmed velocity changes consistent with the JWST profile. No instrument artifacts or timing errors. This movement was real. The conclusion is unnerving. This object is performing trajectory adjustments like a spacecraft. Scientists are clear, it's not drifting, it's steering. Passive debris does not behave this way. This clue shifts the object from mere curiosity to something potentially designed. With metal composition and controlled motion, this object begins to look less like a natural visitor and more like a craft. But before we speculate wild origins, let's explore a grounded possibility. Could be a lone interstellar visitor, like an enhanced Oumuamua, passing through with unfamiliar traits? Here's why scientists are considering that hypothesis. Could this object hail from beyond our solar system? Think Oumuamua, the first interstellar object spotted in 2017. Its trajectory defied solar system patterns. Ours defied gravity rules. Perhaps it's likewise interstellar, carrying uncommon materials and engine-like behavior. Spectrographic data reveals spectral lines not found in solar system materials. Maybe it's made of exotic interstellar alloys. However, it also retains heat in a metallic fashion and manipulates its path. Could an interstellar visitor carry shock-heated metal surfaces and limited self-propulsion from radiation pressure or residual gas? Scientists argued on statistical probability. Every decade, we expect a few interstellar objects, but none have shown active maneuvers. To test self-propulsion versus gravity assist, they ran simulations. The object's braking doesn't align with known acceleration from sunlight pressure. Only tiny thrusters could do it. Interstellar origin remains plausible, but the intentional motion requires explanation. Is it powered or just reacting? If it's interstellar, It's the most complex visitor yet, an unbound metal probe traveling at cosmic speed. And that's more science fiction than science fact. Hypothesis B. Some researchers argue it could be a leftover relic from when our solar system formed, a primordial object dating back 4.5 billion years. In the early days of the solar nebula, clumps of dust and rock coalesced, but many were ejected before they fully formed. This object might be a surviving fragment thrown off by Jupiter's early migrations. It could contain primordial isotopes, radioisotopes, or noble gases from the solar nebula that haven't been processed by planetary geology. Scientists are searching for isotopic signatures that could date it to the formation era. If confirmed, it would be like holding a frozen piece of early solar history. Still, most primordial relics are rocky or icy, not metal-rich, and certainly not maneuvering. The odds are long that a solar system baby relic would contain such high metal content, exhibit thermal inertia, and perform precise movements. The spectrum and behavior don't match expectations for ancient debris, yet scientists remain open-minded. If this is a primordial survivor, its uniqueness would make an irreplaceable scientific treasure, an untouched time capsule. It could tell us about planet formation, early collisions, and how early solar bodies survived or were destroyed over eons. Having explored natural relics, the most explosive possibility remains. Could this object be artificial, crafted by intelligence, perhaps even alien? Its metal composition, heat emissions, and control changes all hint toward design. Let's dive into the hypothesis that this might not be nature, it's engineering. Hypothesis that when every natural explanation falters, the question emerges, what if this is a design object? The object's control movement, metallic composition, internal heat, and electromagnetic buzz align with what we might expect from a probe or satellite. Analogies to Earth technology come up. Small spacecraft like CubeSats use metallic panels and plasma or ion thrusters to maneuver. Add a long-lasting RTG or reactor for power, and a thermal signature, short pulses during engine operation, persistent low-level glow, matches what JWST is observing here. If alien in origin, it could be a reconnaissance or artifact probe left behind by someone with advanced engineering. It may be lying dormant, only firing sporadic pulses to manage trajectory or preserve position. The faint EM signal might be beaconing to a distant parent or simply residual electronics. The implications are staggering. Discovery of non-human technology inside our solar system, hidden in plain sight. It addresses the age-old "where are they?" question with a jaw-dropping answer. If confirmed, this would revolutionize science history and our cosmic worldview in ways we can't yet fully predict. Such a conclusion demands expert scrutiny. Diverse authorities from geology, orbital mechanics, spectroscopy, and SETI lend insight and caution. Their voices bring clarity and depth to the debate. Let's hear what experts think. Interview style. We brought together voices from across scientific disciplines. A planetary scientist commented, a metal-rich object with propulsion outside expected formation trends. This challenges everything we know about asteroid belt populations. One spectroscopist weighed in. These absorption lines don't match known meteorite classes or any mantle-derived material. We've never seen this spectrum before. An orbital mechanics expert added, this trajectory adjustment is deliberate. There's no known natural process, gravity, or radiation pressure that would cause that level of mid-flight deceleration. From SETI, a cautious note. We're intrigued but not ready to conclude alien origin yet. The evidence keeps pushing in that direction. Finally, an anonymous researcher summarized, we're staring at something inexplicable, but until we get more data, we don't know what the word probe even means in this context. Their consensus, the object is unique, nothing natural fits. But while the artificial probe hypothesis is compelling, it's still extraordinary. They await more data and remain cautious as they chase answers. Gravitational checkpoints. As the object's strange path was tracked, it began moving to what astronomers call a Trojan zone, a gravitationally stable region created by the combined pull of the planet and the sun. Specifically, it skimmed near Mars L4 and L5 Lagrange points, the regions where natural debris often parks in a delicate orbital dance. Trojan asteroids typically exhibit predictable behaviors. They cluster into families, follow the host planet's orbit, and stay locked in place due to the balancing of gravitational forces. But this object, it didn't settle. Instead, it drifted to the zone without becoming trapped or ejected. Simulations from observatories modeled both stable and unstable paths through the Lagrange regions. None of them matched the object's erratic pattern. It wasn't just drifting, it was navigating, weaving between the invisible lines of gravitational influence with uncanny precision. These Trojan checkpoints serve as orbital filters. Nothing stumbles through them without being shaped by the local gravitational landscape. The object's passage through these zones was smooth and calculated, like a vehicle skimming around speed bumps on a well-studied road. With gravitational regions mapped and motion confirmed to be unnatural, scientists needed more eyes and more tools. They launched a global follow-up effort. The goal: scan the object with every telescope that could help decode its signature. Next came an unprecedented surveillance campaign, combining radar, infrared, and even radio telescopes. High-tech surveillance. Once the anomaly became headline material among scientific circles, a network of global observatories mobilized. Ground-based radar systems like NASA's Goldstone and Australia's Parkes tracked its movement. Their radar pings confirmed the metallic structure, its reflectivity and thermal echoes more consistent with engineered alloys than space rock. Meanwhile, the team mined archival data from NEOWISE and the now-retired Spitzer Space Telescope. Hidden in the noise, they found subtle prior traces of the object, suggesting it made previous passes through the belt, possibly staying dormant until now. Radio telescopes began conducting narrowband signal sweeps, listening for any beacons, modulated bursts, or repeating patterns. Although no message had yet been confirmed, analysts picked up odd fluctuations in a narrow frequency band. A whisper, perhaps, but one they couldn't ignore. JWST continued spectral monitoring from afar, collecting higher-resolution thermal and compositional scans. With every instrument focused, the object had become one of the most closely monitored mysteries in modern space science. The more they looked at it, the stranger it became, and the question could no longer be avoided. If this object is active, if it's moving with intention, what does that mean? Was it sent for a reason? Is it gathering data? Or is it watching? What if it's active? If this object isn't just moving, but maneuvering with purpose, then we're dealing with something radically different. Its trajectory shifts suggest active propulsion. Its EM signature, maybe its version of communication or telemetry. If it's power, we need to ask, what powers it? Nuclear? Solar? Something we haven't imagined yet? Could it be a reconnaissance probe sampling asteroid materials or surveying planets? Could it have passive sensors trained on Earth or Mars? Its placement between two inner planets could make it an ideal observation platform. That possibility haunts scientists. We've long looked outward for aliens, but what if they're already looking back? Alternatively, it might not be observing at all. It might just be passing through, a relic from another star system, seeded long ago, drifting on a pre-programmed path. But the course correction behavior throws a wrench in that theory. Random relics don't break. Then there's a darker question. If it's active, could it pose a threat? Most scientists think not. Its slow speed, erratic maneuvering, and low-energy signals suggest a passive craft, not an aggressive one. But still, the fact that it moves at all means we are dealing with technology, not geology. Institutional response and secrecy. The moment the object's abnormal characteristics were confirmed, NASA, ESA, and several other space agencies moved fast. A multi-agency task force was created, pulling in planetary scientists, signal analysts, and military liaison. While public updates focus on its scientific intrigue, internal memos revealed a far more urgent tone behind the scenes. Defense agencies became involved. The object's control maneuvers raised flags, not because it was hostile, but because its origin was unknown. Was it a piece of rogue human technology, a foreign surveillance asset, or worse, something not from Earth at all? Containment protocols for sensitive data kicked in. Declassified telemetry reports began leaking into the science blogosphere. Some data matched JWST's published readings, confirming metallic composition and signal flicker. But other details, such as precise object size, origin point, and potential orbital model, remain redacted, sparking suspicion that the full story wasn't being told. Public trust and transparency frayed. Scientists urged open communication, while officials cited national security interests. One researcher quipped anonymously, "If it's natural, why the silence? And if it's artificial, who's holding the truth?" When science touches mystery, the cultural quake is never far behind. The public, already primed by years of UFO discussions and scientific skepticism, began asking the hard questions. Was this proof of alien engineering, a message from another mind? And if so, what should humanity do with that knowledge? Philosophy, fear, and wonder collided in the next phase, philosophical and cultural ripples. The discovery stirred more than scientific debate. It ignited cultural shockwaves. Social media exploded with theories, some credible, some conspiratorial. News outlets dubbed it the intruder of the belt. Documentaries and debates sprang up. Religions, futurists, and technologists all had something to say about what it could mean. For many, this object became a Rorschach test. Was it proof of cosmic companionship, or a mirror showing how unprepared we are for the unknown? Some argue for immediate contact. Others call for caution. Meanwhile, ethicists raise moral questions. If it's intelligent, do we have a right to study in secret? If it's ancient, is it a relic or a sentient ambassador? The scientific community tried to stay grounded, but even the most skeptical voices acknowledged the emotional and philosophical weight. "Even if this isn't alien tech," said one astronomer, "it's changed how we think about surveillance, awareness, and our place in the solar system." Ultimately, the encounter forced humanity to confront existential uncertainty. What if the cosmos has been speaking all along, and we've only just started listening? With global attention locked in and the object behavior far from explained, the focus turned to the future. What would happen next? Would the object vanish into space again? Would it pulse a message? Or was something bigger, something unseen, still coming? The story now turned toward the next phase: global tracking, new missions, and one haunting question: what next? Teams scrambled to schedule new observations. JWST secured imaging time to capture higher-resolution scans across thermal and radio spectra. ESA partnered with China's CNSA, sharing orbital data and planning new probe paths. The object-projected trajectory now intersected with a rarely monitored arc between Mars and the inner asteroid belt. Meanwhile, the Interstellar Mapping and Acceleration Probe IMAP, scheduled for launch, was tasked with integrating anomaly tracking capabilities into its mission. Scientists hoped its wide-field detectors could capture low-energy radiation signatures if the object powered up again or launched a signal burst. Citizen scientists also entered the mix. Programs were launched where enthusiasts could help monitor archived sky maps, scanning for past appearances of the object. The theory: if it's been here before, maybe we've missed it, and maybe we'll miss it again. The world watches. The object continues its silent path. And somewhere far from Earth, maybe a signal is still coming, delayed by light years or time itself. The final message: what we thought was empty space might not be empty after all. It remains silent. It hasn't spoken, but it moved intelligently, purposefully, and in that movement, the object revealed something more profound than a message. It revealed possibility. Somewhere between Mars and Jupiter, an engineered mass continues its lonely drift. The most advanced telescope in human history caught it mid-course correction. It reflected heat like no asteroid. It shimmered in ways no natural rock should. And its presence is challenging everything we thought we knew about our solar system's past and our place in its future. We don't know if it's alien, ancient, or a product of forgotten human ambition. But one thing is clear: its behavior demands explanation, and its silence, whatever it means, is louder than any signal. New missions are being drafted, telescopes retuned, civilian scientists enlisted. The hunt is on, not just to track it, but to understand it. Because whether it's an interstellar relic, a dormant probe, or something else entirely, its existence means we're not alone in the quiet of our own backyard. And that changes everything. We used to think that discovery meant going farther into space. But maybe the first real contact comes not from beyond the stars, but from between our own worlds.